work out the sizing, but ultimately you're looking at a minimum of about one OCPU of database, DBCS, and then one OCPU of Event Hub.
Okay.
So, because that's used for the and the big data is used for analytics. Now that's only OMC. So if you go for AMC, there's none of that. So the difference fundamentally is with OMC, the cost per interaction, and there's a difference between pay-as-you-go and subscription. But if you take subscription, it's roughly 0.014 cents per interaction. But if you look at AMC, it's about 0.28. It's like double, but there's no prerequisite costs. So ultimately, it's cheaper because until you go for really large B2C environments, you're never going to necessarily cover the cost of one over the other. So it's a good way to start. But the nice thing with AMC is the fact that it's easier to basically shut down, turn off. Because one of the things with OMC is you've got to shut down your interactions. So if I'm not doing anything, I don't want to charge. But because the OCPU is on all the time, you have to actually turn off the database. So that's why AMC is a better option if you're looking at starting up.
Okay, cool.
Okay, let's look at the dialog flow. So as I said, we'll start by looking at the dialog flow itself. The important one is the building blocks, which are those components, and then sort of how do I move from one to another. So when we look at a dialog flow, again, look at it from the viewpoint of that passing a ball around. What defines the atomic component of a dialog? So in this case, we've obviously got the question, go and get the sort of additional information. So that's get the entity, get the answer. So ultimately, a flow is going to be made up of various sections or states that define individual components, individual balls of the flow. So ultimately, we can look at each one of these almost as being atomic, as standalone. And we move from one to another based on how we answer where the ball was previously. Now, in the case of the Oracle bot, as I said, this is defined in BotML, or a YAML flow. So it looks verbose, but in reality, if you actually put a simple space between them, you can see that they're really just the sections of the flow itself, and then I can just cut and paste between them. But as I said, we are building, there is the flow diagrammer to build this if you need to, but in reality, it's just faster using a text editor, or just using the editor inside the build environment. So BotML, it's non-procedural, and as you can see, it's really just a series of properties and like attributes and values. So again, what's let's find one here. So the prompt, what's the prompt? What variable are we using to keep track of information? What component type are we using? So in this case, system.list, as the name would indicate, is a simple list in the conversation flow. So they're pretty straightforward, it's very readable, but from a building block perspective, it's broken into different sections. So the first one, the header, is really just metadata about the conversation. It's really version of the conversation. And the name, that's going to be the same everywhere. The context are basically the set of variables you're using to track information. Now this is a big difference to some of our competitors. So I mentioned the term of slot before. Slots are effectively the pigeonhole that you put information into. Now, some of our competitors, and a good one would say Google, their slots are only for entities. In other words, if I've defined an entity, I can slot it, but I can't use slots for other things. Whereas here, our variable model, which equate to a slot, can be used for anything. So it allows you to not only look for entities in the slots, but also to just simply use it as a counter or simply use it as some form of flag. So you can put anything in there. And there are standard types, so they can be sort of primitives, string, number, int, or you can base them on an entity itself. So for example, here's an account type variable, which is of type account type. Now that's an entity. Now where this becomes important is when we do the dialog flow, if I try and put something into a field that is expecting an account type reference, and I put in pizza, it will simply re-ask the question automatically, because it's going to check against the variable, the valid list of values, and if it's not valid, it will ask again until you put a valid answer in. So again, you don't have to do that, it's just inherent in the component. So I said, different types. The NLP result one is this variable contains the output from the NLP engine. So this will be, what's the intent? What entities did I find? What's the utterance that was asked? All of those, I can interrogate that variable and effectively find out what the NLP or the NLU was trying to find. So effectively, this is wrapping up your conversation inside that one variable. So if I pass that iResult variable to, say, a back-end process, that back-end process knows exactly what was asked, what the intents were, and what the entities were. I don't have to go and call various APIs, I simply just look at iResult.string. And the individual states, this is what basically defines the actual dialog flow. So each one of these states represents that ball that we're passing as part of the conversation. So again, think of the conversation flow as a set of atomic states, and we pass the ball around to have this logical conversation. It's not hardwired from A to B to C. So as I said, the states represent this conversation flow. Now by default, it's top down. So if I put no transitions in there, it will do state A, state B, state C. However, I can also define a transition. And a transition, think of it as go-to label. So in this case where I have an open set, let's simply say there is no transition, just drop to the next one. But if I have the name, I can say, we'll go into this next, or if I answered it this way, go here. So what you're doing is you're dynamically saying where to go next by simply setting the transition that you want to use. So transitions, as I said, are the way we get from point A to point B. And there's a number of different transition types. So obviously no transition, empty set, curly bracket, curly bracket. Basically that says go to whatever's next in the file. So simply drop down. Next is effectively hard coding it to a particular endpoint. So whatever happens, go here next. So this is if I was writing basic, this would be go to. Likewise, an error trap. If there's an error, this is a catch-all. If there's an error, go to here. The important ones are this one, the actions. Now return is basically clear out and start again. So return is where if I finish the conversation and I want to clear out all the variables, I simply say return, and that takes me to the top of my tree, and I start again. So return is effectively end. But actions are based on how I answered the question, go to this particular next state.
Is there an implicit order of precedence in those, or is it just whichever one comes first in the YAML file?
So if you're just using no transition, it's whatever the order is in the YAML file. If you're using transitions, they can be anywhere in the file itself, it doesn't matter. So you can bounce up and down quite happily. Because ultimately the engine is a finite state machine. So what it does is it reads the whole YAML file in, and then it basically will allow you to jump around within that same state structure. So the default, as I said, is, you were just seeing the slides, weren't you? So yeah, it's top to bottom. So inevitably it makes sense to try and keep the file in some sort of logical order. What I tend to do is I'll put intent sections together, and then you'll do logical business units together, but they can be anywhere within the file. So the action basically says, in this case, this is my intent one. So the action here is just basically, in this case, we're finding the intent. And if this intent happens, go to this named label. So each state has a label. So in this case, I'm mapping, if this occurs, go to here. If this occurs, go to here. You can think of it as a switch statement, where effectively based on the outcome of the previous function, go to the next function. So you're soft coding the relationship between things. Now return, so you can see here, we're calling a function called print balance. So this is the name of the state. We're calling the backend function print retrieval or balance retrieval. We're copying that into an account type variable, and you can see here we've got curly brackets. So this is implemented using FreeMarker. So FreeMarker is an Apache tag language. The nice thing about that is you can do some really cool things with FreeMarker. So if you want to do sophisticated programming, you can actually use FreeMarker functions and methods inside the strings. In this case, it's doing return print balance. To be honest, here, whatever you put in there actually doesn't make any difference. What it's doing in the logs is saying this is where you ended up. The important thing is the word return. So what return does is clear all the variables and reset your position in the conversation to the start of the conversation. So literally it's end, clear, reset. Next, go to, it's just a hardwired. And as I said, the error is basically says, if there's any error in this state, then basically it returns this named error, and then you can jump to a particular occasion. So it's an error trap, it's a handle. And every component has an error. So there's a number of predefined transitions that you can apply to objects. Error being one of them. You've got unhandled action, or unhandled. You've got text received. So these are effectively predefined labels that you can apply to an object, and then, so text received is basically if I had a menu and I typed in anyway, it will say I received text even though the component didn't actually expect text. So you can use these as general traps to catch things, but advanced course. Okay, so the system components, we have two types of component that make up a conversation flow. The system components are basically the UI elements that you use to build up a conversation. Custom components are what you use to go and get the data, or if you want to do some really snazzy UI that the system components can't do. So a custom component can not only look up data, it can actually render UI elements as well. So if you want to come to the question we had before about different dialects, in your system component, you can change the response based on the logic at the back end. So even though I have the entities, because I have the utterance, I have that NLP result, so my custom component knows exactly what was asked, plus I have locale, plus I have your profile data, all that sort of thing, I can respond in a different way based on information. So I simply say, reply British English, reply Indian English, reply something else. So I can have complete control over that. So if we look at the system components, which frankly is where you spend most of your time designing in the YAML. So that allows us to define the output, as I said, have access to the NLP engine. So if you want to do any custom NLP, you'll do it through a system, you'll do it through a custom component rather than the system components. So when we look at a system component, as I said, it has a number of properties like the prompt, where we're going to store a variable. Now that's important because of the flow. So remember I was telling you about the idea of the conversation flow being a ball? And we had A, B, C. How does it know if I've said